square. Is my voice audible?
Yes, sir.
So what is the check for irrotationality? This is the check for irrotationality. Dou v by dou x minus dou u by dou y must be 0. So if you take the first one, what is dou v by dou x? What is dou v by dou x? Dou v is equal to 4. So what is dou v by dou x? 0. And what is dou u by dou y? Dou u by dou y is again
0.
this doesn't contain y. This doesn't
0.
contain x and this doesn't contain y. So therefore, both dou v by dou x and dou u by dou y are 0. So this is irrotational. So this is irrotational. The first one is irrotational. So similarly, you find the remaining three. Okay, that is one part. Then find the vorticity of each of the flows. So what is the expression for vorticity?
Twice of rotation, sir.
Okay. So vorticity, if you take expression for vorticity is dou v by dou x minus dou u by dou y. Okay. So dou v by dou x minus dou u by dou y. Dou v by dou x minus, sorry, that's what. Dou v by dou x minus dou u by dou y. So what is that value? Dou v by dou x minus dou u by dou y, 0. So the vorticity is 0. So like that, you find out for the remaining things. In fact, you will see that those cases where the flow is rotational, you will get the value of that. And irrotational, you will get 0. Okay. For the first one and the last one, for this one, for this case and this case, these two cases are irrotational. These two cases are irrotational. You can see here.
Sir, for rotational, half into dv by dx minus du by dy, sir.
That is the angular velocity. Vorticity is this expression. Vorticity is dou v by dou x minus dou u by dou y. So twice the angular velocity is vorticity. Understand?
Yes, sir.
So you can see for the second case and third case where the flow is rotational. See here, this is rotational. Are you seeing this? Okay, this is not possible. Okay, right. I will do one thing. the flow is rotational. Have you seen? So accordingly, for these two cases, for this case and for this case, you are getting the values of vorticity. For the remaining, for this one, it is irrotational. So this is 0. And similarly, for this case, this is also irrotational. So here also you are getting 0. So this is how we can calculate, we can find whether the flow is rotational or irrotational. Now, let us take another problem. The flow of an incompressible fluid is defined by U is equal to 2 and V is equal to 8x. So, U is equal to 2 and V is equal to 8x. Does a stream function exist for this flow? If so, determine the expression for the same. So, this is the problem. All of you note the problem. U is equal to 2 and V is equal to 8x. So now, for this case, it is given that it is a flow field. Okay. And the velocities are given. So now use the definition for U. U is equal to dou psi by dou y. And definition for V, stream function, minus dou psi by dou x. So you take this expression and integrate it. So if you integrate this, what you will get? Dou psi is equal to 2 dou y. One. If you just take this part, dou psi by dou y is equal to 2. So dou psi is equal to 2 dou y. So if you integrate, psi is equal to 2y plus a constant of integration. I have written here fx. Now, it can be a constant or it can be a function of x also. Because if this is a function of x, now if I differentiate this with respect to y, I will be getting dou psi by dou y is equal to 2 plus a pure function of x. So what is the derivative of a pure function of x? What is it? dy of 3x. d by dy of 3x is 0. Because that fx is 3x, and if we differentiate it with respect to y, we will get 0. So therefore, when we are integrating this, we will get one function, one expression plus a constant or a function of x. Similarly, if we take this, v is equal to dou psi by dou x and minus v equal to, and it is given as 8x, v is equal to 8x. So you equate dou psi by dou x to minus v, that is minus 8x. And if you integrate it, you will get dou psi is equal to minus 8x dou x, minus 8x dou x. So if you integrate minus 8x dou x, what you will get? Minus integral x dx is x square by 2. So this it will be minus 8x square by 2, that is minus 4x square. plus a constant of integration or a pure function of y. So now we got psi is equal to 2y plus a function of x, and psi is equal to minus 4x square plus a function of y. So if you just combine, if you replace this function of x by this, and if you replace this by this, you will get fx is equal to minus 4xy and fy is equal to 2y, and therefore a stream function does exist, and it is psi is equal to combination of these two, minus 4x squared plus 2y, right? Now, I can also say that psi is equal to minus 4x squared plus 2y plus or minus a constant. That can also be considered as the stream function, because if we add for this plus or minus some constant, still the velocities will be given by these expressions only, right? Do you all understand that point? Now all of you write down psi is equal to minus 4x square plus 2y, and also you write below that psi is equal to minus 4x square plus 2y plus constant, and you will differentiate it with respect to x and differentiate it with respect to y, and see whether you are getting the velocities u and v or not, because the derivative with respect to derivative of constant term will be 0, so there will not be any change. So therefore the answer is this plus or minus a constant also can be considered. Is it clear, all of you? No. So in the earlier case, it is given, in the earlier problem, it is given that there is a flow. Now what we are taking a different, the following flows, write an expression for the stream function if one exists. So here just simply I have given two problems saying that the velocity is given by u is equal to 2 plus 3x, v is equal to 4, and u is equal to 3xy minus 1.5 x square. So these are the two problems. First problem is u is equal to 2 plus 3x and v is equal to 4. And the second problem is u is equal to 3xy minus 1.5 x square. So for these two cases, you have to find the expression for stream function. Now, before finding the expression for stream function, is that such a flow exists. If the flow does not exist, then the question of stream function does not arise. So when can you say that the flow exists? You can say that the flow exists only when the continuity equation is satisfied. Now what is the continuity equation? This is the continuity equation. This is the continuity equation. So now take this first case and verify whether the continuity equation is satisfied or not. If it is satisfied, then use this procedure. Use this procedure and find out the expression for psi. If this is not satisfied, then the question of psi doesn't arise at all. Come on, all of you do it. I'll give 10 minutes time for you. Another one. Gee, let me see whether this is satisfied or not. Now let us take this one. U is equal to you check for this. U is equal to minus 2xy minus 2x to the power of 4 plus 2y to the power of 4. And v is equal to 4xy minus x to the power of 4, y to the power of 4. You check for this.
Sir, exist out means
Ah.
satisfy out means sir.
So find out, now you find out psi. So find out psi. Zero, 1, 2, 3, 4. Minute. This is the problem. You note down this problem. This is the problem. Sketch the streamlines, size equal to 0, size equal to 1, size equal to 2, size equal to 3 for the following flow fields. Note the values of u and v and verify the continuity is satisfied in all cases. So this is the problem. The cases are A, size equal to 10y, B, size equal to minus 20x, C, size equal to 10y minus 20x. Now, all of you look at this problem. Now I will explain the first case. A equal to A, size equal to 10y. A flow represented by a stream function psi equal to 10y. Now what you are supposed to do is, you are supposed to verify whether the continuity equation is satisfied or not. And also you have to find out if the continuity equation is satisfied, then you have to find out the streamlines corresponding to psi is equal to 0, corresponding to psi is equal to 1, psi is equal to 2, and psi is equal to 3. So now let us take. So this is the expression for psi. Now what is the continuity equation in terms of psi function, stream function? What is the continuity equation in terms of stream function? I have
Dou square phi by psi
Uh,
by dou x, right?
Laplace equation in terms of psi. Del square psi by del x square
Plus
plus
del
del square psi by del y square must be 0. Okay? I will show that. See? In terms of new function, so see this one. In terms, or rather you can say take this continuity equation and you can calculate from this expression for psi, find out uv. See, take this psi and find out u and v. What is u equal to? Dou psi by dou x. So u is dou psi by dou x.
Dou y, sir.
Sorry, dou psi by dou y. U is equal to dou psi by dou y. So what is that value? It is 10, right? And what is it? V? V is
0.
0. V is 0. So what is dou u by dou x? U is 10, right? U is 10. V is 0. U is 10 and V is equal to 0 for this case. See, for this case, U is 10 and V is 0. So what is dou u by dou x? What is dou u by dou x?
0, sir.
Dou u by dou x is 0. And what is dou v by dou y? Dou v by dou y also is 0. Both dou u by dou x and dou v by dou y are 0. So therefore, the continuity equation is satisfied for this case, right?
Yes, sir.
Now you have to plot. So psi is equal to 0. Psi is equal to 0. So psi is equal to 0 means, now here, what is psi equal to 0 means? This is the line. Psi is equal to 0. See, in this expression, what is the expression for psi? Psi is equal to 10y. So the equation is ny is equal to 0 or ny, okay, that's all. 10y is equal to 0. So this is the equation. Ny equal to 0 or y is equal to 0. So y is equal to 0 means what? Y is equal to 0 means it is horizontal line. See, if I draw y-axis and x-axis, if I draw this is x-axis and this is y-axis. right? So this is x-axis and this is y-axis. So all along this line, y is equal to 0. So y is equal to 0 indicates x-axis. Similarly, x is equal to 0 indicates y-axis. Okay. So this is the streamline corresponding to psi is equal to 0. Then psi is equal to 1 will be another line. Another line. This is here it has shown 10. So psi is equal to 20. So these are the streamlines. This streamline is psi is equal to 0, psi is equal to 1, psi is equal to 2, psi is equal to 3. Like that, anything you can show. So what is the type of flow? The type of flow is a flow parallel to x-axis. So psi is equal to 10y indicates a flow which is parallel to x-axis, right? Now similarly, if you take this one, the second one, if you take this one, second one, psi is equal to minus 20x. So psi is equal to minus 20x also satisfies continuity equation. Psi is equal to 20x also satisfies continuity equation. And for that, what you will get? What is u for the second one?
0,
Zero, sir.
U is equal to 0. And v?
minus 26.
No, not minus. V is 20. U is plus 20. Because V is minus dou psi by dou x. V is minus dou psi by dou x. So psi is equal to minus 20x. Therefore, V is equal to minus of minus will become plus 20. So U is equal to 0 and V is equal to 20. So again, continuity equation, dou U by dou x is 0 and dou V by dou y also is 0. So therefore, the second case also represents a flow field, and now this is the equations psi is equal to minus 20x. So now the new equation is minus 20x minus 20x is equal to 0, or x is equal to, so x is equal to 0 is the equation of the streamline. So x is equal to 0 means what?
It is horizontal.
A horizontal line. No, x is equal to 0 is not horizontal.
Vertical
X is equal to,
x by
x
x.
is equal to 0 is vertical line. Because all along this, x is 0. If you take any point on this, x is 0. So x is equal to 0 indicates a vertical line. So these are all the flows. So therefore, psi is equal to minus 20x indicates a flow, parallel flow in the vertically upward direction, right? Now psi is equal to, now I am giving psi is equal to, instead of minus 20x, I am giving it as plus 20x. Similarly, first problem, instead of psi is equal to 10y, I am saying psi is equal to minus 10y. Now find out what is the type of flow. Psi is equal to minus 10y indicates what? How can you say no? In the first case, the flow is taking place from left to right. The flow is taking place from left to right. And in the second problem, I have shown that the flow is taking place vertically upwards in the positive y direction. In the first case, I have shown that the flow is taking place in the positive x direction. Now, how could I say that? Can anybody tell? On what basis? There is no doubt that the flow pattern is parallel. But whether from left to right or right to left, both are parallel. On what basis I have written that the direction I have shown from left to right in the case of first problem?
Sign indication.
Eh? Which sign?
Positive.
What positive? Which quantity is positive?
Y value is positive.
Y value can be anything.
Okay.
See, you look at our calculations. What we have calculated?
U is value, sir.
Exactly. U is equal to plus 10. Isn't it? For the first case, what is U?
Plus
10.
10, sir.
Plus 10. So that means
Plus
the velocity is in the positive x direction. Right? Now,
Yes.
for the second case, what is V?
Positive.
It is plus 20. Plus 20.
Again positive.
That means it is in the positive y
Positive.
direction. Now I am saying that the problem is psi is equal to, instead of 10x, minus 10x. So that means the flow will be now
Right to left.
right to left. And in the second class, when I say psi is equal to 20x, sorry, psi is equal to 20x. So it will be top to bottom in the negative y direction, because in that case V will be dou psi by dou x, that is minus dou psi by dou x. So minus dou by dou x of 20x, that is minus 20 units. So therefore it is flow is from top to bottom or in the negative y direction. Okay. Now all of you look at the third problem. All of you note this third problem. Psi is equal to 10y minus 20x. And also one more problem. This one. This problem. A flow field is described by the equation psi is equal to 1.2xy. Sketch the streamlines in one quadrant for psi is equal to 0, 1, 2, 3, 4. So in one quadrant means you can take like this. So you can take so what you can do is, so psi is equal to 1.2 xy. Psi is equal to 1.2 xy. And you are asked to sketch the streamlines in one quadrant. For psi is equal to 0, for psi is equal to 1, psi is equal to 2, psi is equal to 3, psi is equal to 4, like that. So how do you proceed with this problem? All of you note this problem and the third problem here. The third problem is this one. Psi is equal to 10y minus 20x. So these are the two things. So this is one problem. This one problem, psi is equal to 1.2 xy, and the other problem is psi is equal to 10y minus 2x. For this case, this is this solution. So all of you work out these two problems. Now I will stop here. V is minus 1.2y. So dou u by dou x is 1.2 and dou v by dou y is minus 1.2. So in the continuity equation, I'm sorry.
కాఫీ కలిపేనా ఇచ్చిందే
అయిపోయింది.
కాఫీ ఇచ్చిందా కలిపేనా అంటున్నా
ఇచ్చింది. So the continuity equation, there is a problem. Okay. So here it will be 0. So the flow exists. Now what you have to do is, Now you look at this. So psi is equal to 1.2xy. Now what you have to do to get streamlines, you have to equate a to a constant. So now the equation of streamline is 1.2xy is equal to constant, or y is equal to constant divided by 1.2x. Now problem, it is given, you are asked to draw the streamlines for psi is equal to 0, 1, 2, 3, 4. So now what you do is you take, replace the constant value so consider the constant value as 0, 1, 2, 3 and 4. So you will get 4 equations. 1.2xy is equal to, or y is equal to constant by 1.2x, that is y is equal to 0. Then if I take constant as 1, y will be y is equal to 1 by 1.2x. That is second equation. Third equation is y is equal to 2 by 1.2x. That is third equation. Fourth equation is y is equal to 3 divided by 1.2x. And last equation is y is equal to 4 divided by 1.2x. Now what you will do is, you take different values of x. Say for example, x is equal to 1. X is equal to 5. You substitute here. For all values of x, 1, 5, 10, 20, 25, the y values are 0. So this is one line. This is one streamline. Then you take second equation. Y equal to 1.2 into 1. So next value of y, so you will get a set of xy coordinates. From this equation, one xy coordinates. From this equation, one xy. So what you do is, so x and then corresponding y. So x is equal to what? 1, 5, 10, 20, 25. So like that, use each equation. 1 minute. So this is equation 1. Then similarly, so from second equation, then third equation, fourth equation, fifth equation. So from first equation, the values of y are 0. So second equation, 1 by 1.2. Then 1 divided by 1.2 into 5. And then, so like that, so this is 10, 20, 25. So like that, so second equation here it is 2. 2, 2, 2, 2. Here it is 3, 3, 3, 3, 3. Then 4, 4, 4, 4, 4. So what you can do is you can take this and draw the pattern. What I will do is I will show you
Sir, at 20th column, you
yes.
put 3.
Huh?
20 దాంట్లో చివర్లో 3 టైప్స్ సార్ 4
Okay, what? Don't bother about the accuracy. Okay. See, there may be some
ఓకే
because the procedure you must to follow. Other So something like that.
Excuse me, sir.
Okay. Yes. Anyhow, I am winding up. So this is an approximate way in which we can draw, right? So Monday, I will